Hello and welcome to the WGG how-to video for Magical Mirrors Kaleidoscope. In this activity, learners will design an optical device known as a kaleidoscope to create a visually interesting image. To realize this optical artistry, learners will take on the role of an optical engineer. An optical engineer applies their knowledge of optics, or the properties of light, to design components of instruments such as lenses, microscopes, telescopes, fiber optic communication systems, and lasers. The STEM big idea for this activity is reflection. This diagram explains the law of reflection. It shows a light ray approaching a reflective surface, such as a mirror. The light ray bounces off the reflective surface, similar to the way a ball bounces off a hard surface. Note, the angle of approach to the surface is the same as the angle of departure from the surface. This law of reflection explains why you see your image in a mirror. The materials you need for this activity include a kaleidoscope kit, which contains a tube, mirrors, plastic chamber, and a chamber cover. You will also need an assortment of colorful beads, both opaque and translucent, tape, and paper plates. Before the kids walk in, you want to make sure that you have familiarized yourself with the design challenge. You have all your materials that you need ready to go. You've read the facilitator guide as it contains many important details for this activity, and you've set the activity up so that when the learners come in, they can begin to have fun. There are several ways to get the kids excited about this fun hands-on activity. You can show learners images of kaleidoscope visuals, pose questions to elicit their ideas, ask, "What do you see?" Or more specifically, what shapes, colors, or patterns do you see? What makes these images visually pleasing? And what are your ideas about how these images are created? You might pique other learners' interest by explaining or sharing with them the etymology of the word kaleidoscope, meaning to look at beautiful forms. Finally, consider a metaphorical introduction to this activity. For example, this quote reads, "Life is like a kaleidoscope, ever-changing, intricate, and beautiful." Discuss with students how an application of science might offer an explanation of life. Whichever approach you choose, remember the introduction is the opportunity to elicit students' ideas and have them share with others. Now, let's check out some highlights for this activity. As always, when learners log into the WGG environment, they will view a set of steps for this activity. The first step will provide an overview of the activity and preview the design challenge. In this activity, students will use 3 design criteria to evaluate their kaleidoscope design. Image clarity. Can you see the objects in the kaleidoscopes? Are those objects fuzzy? Is the image clear? Image repetition. How often does the image repeat itself? And image variation. Does the image change with each use or turn of the kaleidoscope? Next, learners will engage in a series of knowledge and skill builders. First, they will observe what happens when one bead is placed in front of one mirror. To answer the question, "How many beads do you see?" learners must count the actual bead and the reflected image of the bead. For example, I see 2 beads. Next, learners will observe one bead placed in front of 2 mirrors that are taped together. Encourage them to experiment with the distance the bead is placed from the 2 mirrors. They may also experiment with the angles the 2 mirrors make. Learners will also have the opportunity to connect all 3 mirrors into a triangle, both short and tall, and to observe the number of beads that they see. After this series of knowledge and skill building activities, learners will now get the chance to create their kaleidoscope. First, learners will tape the mirrors into a triangular prism. Then they will place the prism into the cylindrical tube. Next, learners will insert the top of the plastic chamber into the cylindrical tube so that it is against the triangular prism inside the tube. They will add their selection of beads to the plastic chamber. Here, encourage learners to experiment. What affects the clarity, repetition, and variation of the image? Is it the amount of beads? Is it the shape or color of the beads? Or even the size of the beads? Does it matter if the beads are opaque or translucent? After learners have decided on their bead selections, have them tape the glass chamber to the tube. After looking through the eyepiece, they can now evaluate their design based on clarity, repetition, and variation. Finally, we have a few facilitator tips where the gotchas can get you. As mentioned before, encourage kids to play with varying the mirror angles before they build the kaleidoscopes. Also, talk with kids about how different beads let light pass through. The beads that are opaque, light does not pass through. The beads that are translucent or clearish looking, light passes through. Also, note that the number of beads affects the image. This is why it's important to encourage that experimentation while students are creating their kaleidoscope. Finally, encourage redesign using different beads, the amount, the type, and the color. And as always, have fun.